Yesterday we spoke about different functions and features of servers and the evolution of servers. Um, the type of servers that we have: the tower server, the rack server, and the blade server. And we also spoke about the server hardware and how all these would work together in terms of your CPU, how your CPU work, how the input devices will take the information from the user. So let's say you on a keyboard, you type something, or on a mouse, or on any input device, which will introduce a certain information or a certain command to the computer, and that command will be converted into a binary code. And from that binary code, it's going to go into the CPU, which is going to be, that information will be taken by the register. And then what the register will do, it's going to take that information. If there is any calculation that needs to be done, it's going to be done by the ALU, and then sent to the output register, to the output device. So whatever device is being used there. Okay, so um, so now that information needs to be converted into binary. Why? Because that's the language that the CPU will understand. So the CPU will only understand binary code. So uh, that's how the information is sent. So the CPU has what we call frequency. So the frequency of the CPU is also called clock speed, right? So this is measured in megahertz or gigahertz. Uh, so this is the frequency at which the CPU will process all the data. Okay, so the CPU process all the information. So this will actually refer to how many cycles or operation the CPU can perform per second. Okay, and then the unit will be the megahertz or gigahertz. So this will be the so basically when we say one hertz is equal to how many cycles per second, guys? What is the meaning of 1 hertz? How many cycles per second is in 1 hertz? Does anyone know? So 1 hertz is one cycle. One cycle per second. So in 1 second, one cycle. So that's 1 hertz. So when we talk about 1 hertz, so we're talking about one cycle. So which means that 1 kilohertz will be 1,000, and 1 megahertz will be 1,000,000 cycles per second, and 1 gigahertz will be 1 billion cycle per second. Okay, so if we talk, for example, they say this CPU, you check on your computer, it's showing you that the CPU is running maybe at 3.5 gigahertz. Gigahertz. This means that your CPU ran about 3.5 billion clock cycles every second. All right, so uh, uh, so that is how you actually measure that. So you will see that in many computers they will give you that information. Why does it matter? Why does it matter to know at how many cycles does your CPU run at? Because it's very important, because the higher the frequency, the faster all the processes are happening in that computer. But also you need to know that it means also that that device is going to use more power, and it's going to overheat easily. All right. So Uh, so now we have these modern CPUs. They don't just rely on the frequency. They also have like multiple cores. Like you have the architecture that has been created that can also improve everything in terms of the performance. Okay, so you need to understand that the CPU frequency is the speed of the processors in terms of how it's performing all the instructions. Okay, so it's very important to have so we have external frequency, we have bus frequency, and then we have multi-factor frequency. So the frequency, sometimes when you buy when you buy your computer and then you check the specification, they you will see it's gonna tell you what's the frequency of that CPU. So when you want to compare it with other devices, it's better you go uh, for a device with a high frequency, because you understand that this is how fast it's going to process all the data. So when we talk about like external frequency, in you can see in other book or other material, the external frequency can be referred as the FSB, right? FSB. Okay, so the FSB will basically be a front side bus frequency, front side bus frequency. Okay, so this is basically the speed at which data travels between the CPU and other components such as the RAM. You know, you have your RAM memory, you have other chips in terms of your input and output controller on your the way the informations travel between your CPUs and your input and output controllers. That is controlled by the that is measured as the external frequency. Okay. So when you think about the external frequency, think about it like you know, like the highway limits that you have. They will tell you on a highway you can only drive at 120 or something like that. So this external frequency is the maximum speed at which information, at which data can move in and out of the CPU. That is the external frequency. And then when we talk about uh, the bus frequency, right? The bus frequency, this will directly affect the speed of the data exchange between the CPU and the memory. So what does that mean? It means when it's basically when you have your what you call that, um, your external devices or your memory, in terms of like certain chips that you have. So you have uh, your processors that are going to be measured in terms of the speed. You understand? So you have other chips that are actually plugged or connected to uh, your processors. Okay. So and then we have the multiplication factor. So the multiplication factor will just be the ratio of the dominant frequency to the external frequency. Okay. And all right, and then okay. So when we talk about when we talk about memory, okay, when we talk about memory, we on a computer, it's not just the storage in terms of the hard drive, right? So when we talk about memory, we also focus on the random memory. So those when the random memory means that the memory that you have for a time, the temporary memory, not just the information that you save. Definitely no. Remember when, for example, you are doing any work, you have things open on your computer. The computer needs to remember what is open, but as soon as you switch off the computer, it forgets what was open. So that is what your RAM your RAM is doing. So when we talk about memory, we also focus on RAM. So the memory will be the storage. We'll have the main storage, where in the main storage we're going to have the internal storage, which can be the storage that the CPU is going to have when certain applications are being used. Okay, so you can have a memory that is just temporary on the RAM, or you can have other memories that are actually memories that even if you switch off your computer, the memory is still there, you still have your computer. So those are, for example, your hard drives. Okay, so it's very important to understand the memory and whatever chip that you are using, what's the memory. You have, for example, those circuit card. People always refer them as RAM. You have maybe specification of them. You have maybe DDR1, DDR2, DDR3. So those ones, for example, you can find a computer that has an 8 gig of RAM. So this computer is going to process data faster than a computer that has a 4 gig RAM. All right. So with a certain softwares, for example, softwares that will help you in terms of editing, you know, those big softwares such as Photoshop, you have your Adobe Lightroom and all those big softwares. You realize that some softwares, they will tell you the computer needs to have a minimum of 16 gig RAM. So if your computer has less memory than this, that program is going to be crashing. So that is very important. Why? Because remember, the program has to send information, data to the CPU and communicate with the CPU in real time. And if your memory, this RAM, is less than 16 gig, that communication is not done properly. So that becomes now a problem. Okay, so that becomes a problem because there will be no fast communication between the software that you are using and the CPU. So you need to understand that when we talk about memory in a computer, we refer to the electronic storage space that the CPU uses, right? It can be to store the data or to retrieve data when performing tasks. So that is very important because when you're executing all the instructions, sometimes the CPU needs to hold certain information for a certain time only as a temporary memory. So that is why a RAM, the random access memory, is very important. So the RAM is what we call the main memory of the computer. All right, so the RAM, but remember one thing, the RAM will only keep information as long as the computer is still on. If you switch off the computer, everything is deleted from the RAM. Okay, that's why the RAM is considered to be a volatile memory, because all the information disappear as soon as you switch off your device. And then you have non-volatile memory. For example, your hard drive. So your hard drive is considered to have non-volatile memory. It means even if you switch off your hard drive, you still have information. Okay, and then you also have the ROM, which is the read-only memory. So basically, this will be kind of the firmware itself, like on the software, like when you open your computer, some people will call it the BIOS. The BIOS. So you see, when you, for example, you have a problem with your computer. If you have a problem with your computer, for example, with the operating system, you want to reinstall it or you want to remove it, there is a part of the computer that is not a part of, for example, Windows. It's just the BIOS of the computer. So that part is saved on the ROM memory, read-only memory. So those are very important. Okay. So it is very important to make sure that whatever you want to do, you understand this. Okay. Okay, so and then you have um, uh, the drive on the computer, which is a very important storage device on the computer. Uh, we all know the hard drive. When you have your hard drive, if you have a very small hard drive, obviously you're not gonna store enough information. You're not going to store enough information, so which means that you are limited. So when you are getting the device, you are getting either a computer or a server, so the drive is very important. If you are planning to store a lot of data, it is very important. So we need to understand the drive is just an hardware device that provide a long-term storage. Why we said provide a long-term storage? It's because when we refer to the memory, we refer to the RAM, for example. The RAM just keep information in temporarily and use that information. So what when we have the drive, so this is the main storage. So it's going to keep information for as long as you don't delete them. So if you don't delete the information, they will still be there. So we need to understand the drive will provide the long-term storage for data and all your programs, the operating system, and then it is non-volatile, but the RAM is volatile. Okay, so you will see we'll refer sometimes you're looking on your computer or any device to specification, and then they will tell you maybe HDD, which stand for hard disk drive, right? You will find maybe you have a hard drive of maybe 500 megabytes or 1 gigabyte. Okay, you have not 1 gigabyte. 1 gigabyte, what's that? That's a small computer. 1 terabyte. Okay, so 1 terabyte. So that can be uh, the the the, um, the hard drive that you have. Okay, so and then remember now there's a difference between HDD and SSD. Both are drives, right? Both can be considered as drive, but the HDD is basically what you have installed on your computers, like the hard drive that you have, right? So that is basically the hard drive that you have, which can be 1 terabyte, 2 terabyte. And the thing is, it is in terms of managing how information are being sent, it is a bit slower, right? It is slower, uh, but it saves more information. You understand? Uh, it is slower than the HDD is slower than the SSD. So the SSD is basically what we have, like the when you have, for example, your USB. A USB can be considered as an SSD. So information um, will move faster. So you have an SSD, which is a solid state drive, right? So it can be either an external hard drive or it can be an internal hard drive, but built as an SSD. So if it builds as an SSD, you must understand that it's going to be faster than HDD. So when you look at the device, the hard drive is specified as an SSD, you understand it's faster than a HDD. So you can find it in laptops, in desktops, but it's more expensive. The device is gonna be more expensive if it has an SSD compared to an HDD. Okay, so the device is gonna be a bit more expensive there. Okay, and then you can also have different other external drives as your USB, your external hard drive that can be an HDD or an SSD. You understand? So those are mostly used for backup, or like external storage for you to just keep your information or your data in there. Okay. And then we have a RAID controller card. So the RAID controller card, this is just a card that can be added to a device, or some device comes with it. So you'll understand that when you're dealing with this data, or you're building this program, especially when you're training AIs and everything, sometimes you will have to add certain card to your computer. So you can take the normal computer that you have, maybe you have a tower, but you need to be experienced in that. There is certain things that you can change to accommodate the type of project you are working on. So when we're talking about an example of a RAID controller card, which is also called a RAID card. So the RAID will stand for redundant array of independent disk. So redundant array of independent disk, right? So this is just a controller card. So this device will just manage multiple hardwares. Okay, so if you have you can have multiple hardwares, multiple hard drives, I mean. So you have multiple hard drives in your system, which you're going to combine and use them at the same time. Okay, so now if you're working on a big project, you have many hard drives, so you want to combine them and work together from multiple hard drives. They can be HDDs or SSDs. So you want to combine them into a RAID array, then we're going to use a RAID controller card. Okay, so the card will control how the data will be stored, how you're going to distribute this data across different drives, depending on the RAID level. So depending on what type of card you have. So some card can be a RAID level 0, 1, 5, depending on how it was done. So you have the main purpose of this, using this, is just to improve the performance of your system, right? To improve the drive performance and reliability, or both, obviously. Okay, so the type of RAID that you're going to have, you have basically you can insert this physical card into the server or a computer. Some of them have their own processors, and then this will help be more faster and reliable. Okay, so some of these RAID card can just be cards to just improve how the operating system is going to work. You know, so you will have, they will call, in that case, they will call them software RAID. So those ones are just there to improve how the operating system will work, to make sure that the operating system is faster or something like that. Okay. So you need to understand. So the RAIDs, just for you to understand, the RAID card are just hardware that will come and act as traffic managers, just to decide how data are written or read from multiple drives. Okay, and just improving everything in terms of the performance and the reliability. Okay, so basically, in terms of the virtualization, when we combine multiple disks, so we have maybe disk 1, 2, 3, 4, and then we have the RAID chip, which is going to actually control that. Okay, so that's how it can be implemented. We have all the disk, and then we can have a RAID controller, and then so before the information from this disk are sent to the CPU, they go through a RAID controller card. Okay, so this is what I said. So we can have a RAID that is just there for software. So it's gonna call a software RAID, or we can have a built-in RAID or an external RAID, depending on what type of of functionalities we want to have, and they will have their own advantages there. Okay, so now another hard way another hard way that we have the NIC, or also called a network adapter, right? So the NIC and the network, or the network adapter, this is just going to help in terms of how we are handling the network, right? This is just a network interface card, which is part of the computer. Or we can, if we want certain specification, we want to improve the performance, we can actually add another one which will have a function of fixed network address, data sending and receiving, data encapsulation and decapsulation, link management, encoding and decoding. So the network adapter, this is just going to help in terms of allowing the computer or the server to connect to a network. So it can help to connect to your Wi-Fi or to any external network. So that will really act like a bridge between the computer and the network. So when you have your Wi-Fi at home, you have your computer, and then you connect to the Wi-Fi. So the chip on your computer that is working in terms of connecting the computer to the network is what we call the NIC. So NIC stands for Network Interface Card, right? So NIC stands for Network Interface Card, or it's also called a network adapter. So this chip will help you in terms of connecting the computer to a network. It can be via a cable. Guys, how do you call if connecting the internet via on a wireless system with the Wi-Fi, right? And when you use a cable, how do you call that cable? How do you call that that way of connecting the internet to the cable? How do you call that type of internet which is connected through the cable?
Ethernet.
Yes, it's called
line email.
Yes, it's called Ethernet. So we have yes. So you have your Ethernet. So when you connect it to the cable, so this NIC is going to help in terms of connecting the computer to the network. It can be via Ethernet or via Wi-Fi. Okay, so, and it also help in terms of converting all the computer data into network signals. So you need to understand the network just understand electrical signals. So whatever information is happening on your computer, guys, you need to understand that those information, from the time it comes as data from your applications or anything, from the time it goes into the whole system, it needs to go through this card so that this card can help those data to be converted into network signal, which are electrical signal or radio signals. Remember, I said last time that the internet is just like your Bluetooth and everything. It uses a radio frequency. It uses radio signals. So for that conversion, for those information to be converted, so that's when you use the NIC. So the card that help you on a computer, on a motherboard, the card that help you is called the NIC, Network Interface Card. That will help you. Okay, so every NIC card will have a unique MAC address. So, you know, it has a fixed network address. We call them a MAC address. You can check even with your computer. It's very easy. That's why it's very easy to identify during an investigation, to identify which computer sent a certain information. because we can identify it through the MAC address, because the MAC address is embedded into the NIC card. So each NIC card has a unique MAC address. Okay, so that's how the NIC will work. So there's different type of card, which will be, I'm sure you've seen these on computers. So these are behind those plugs that you see where you plug your Ethernet. Those are examples of those NIC. You have many types of NIC card. Okay, so it's going to depend also on the type of devices that you have. So different devices will have different cards. So that's very important. But what you need to understand is just that these devices will help in terms of controlling what's happening over the network. So with the Huawei server NICs, the type of NICs that we have on Huawei, we have the LOM card, you have the PCIe card, you have the FlexiO card, and then you have the mezzanine card. Okay, so they all work in different ways. Okay, so those, and they have different specification, different ways of transferring information through the network as well. All right, and then you have the PSU. So you have the PSU and fan module, right? So the PSU and fan module, in this case, so these are just the supplies power to the server. So these this will help you in terms of power supply. If there is any power supply failure, so it's going to help in terms of fault warning and prevention, pre-fault, preventive maintenance, non-disruptive server services. Okay, so when we have a power supply for the servers, it comes with an intelligent PSU and a fan module. Okay, so the PSU just stands for power supply unit. Okay, this is power supply unit. So the power supply unit is just a component that will provide a stable electrical power to the server. Okay, so when you plug it to the electricity and then it goes through the PSU, so the PSU will actually convert the AC. So AC, what is AC? What does AC stand for, guys, when it comes to electricity? Anyone knows? Does anyone know what is AC? Anyone has done electrical engineering or has some electricity knowledge? What is AC?
It's a current. I don't know what current.
Yeah. Current is the C.
Oh, it's alternating.
Alternative current.
Yes, alternating current. So you have the alternating current and the DC, which is the direct current. Right, so these are type of electricity, type of currents that go. But now the CPU, you know, all your CPUs, all your memory, the storage. So all those devices in your computers, including the NIC. This is why when you have a computer, the whole, you know, the big one, the tower there, when you have that tower, you have to be careful if you open it. There is certain section of the motherboard where if you touch it, you're gonna get electrocuted. But for other places, you have a different current. So now the PSU, that's the job of the PSU. So when you plug here, you plug the AC, which comes from your sockets. How many is that? Is that 220, right? 220 volt or 120? What do we have in our home? Is that 220 volt, right? Am I right? Am I right, guys? Guys, am I making sense? The electricity we have in our home, in our socket, is that a 220 volt or 120? 220. Which one is that, guys? 220, right?
Yes, I think it's 220, sir.
Yeah, 220, yes. So now this PSU, what it's going to do, it's going to take the 220, which is the alternative current, and convert it into DC, which can be maybe your devices, other chips on your card, on your computer that are using maybe 12 or 9 volts. 12 or 9 volts. Okay, so this is a converter. The PSU will play the role of a converter. It's going to convert the electricity you get from your sockets, the 220, convert them into the 12. So the PSU, the PSU in a server will play that role of converting that, so that there's no 220 going to the storage, the memory, all your NICs. They don't receive so much power. So that's the role of the PSU. Okay, so some servers will have multiple PSUs on them. You can replace one without shutting down the server. You know, when you have like big companies where there's big servers, and then they can't shut down the system. So if they want to maintain or replace, they can replace others, and then the system can continue working because there's backup PSUs, right? And then the fan module, this device is just to provide a cooling to the server. It's just gonna allow like a proper airflow through all the how you call that, the CPUs, the memory, the drives, to avoid an overheating. So that is the fan module. Okay. So you need to understand that the fan module, just like the PSU, for big servers, or for all those big servers you have in big companies working on many data, there is multiple fan modules, so they can be replaced without shutting down the whole system. Everything can be replaced and they can work. So you need to understand PSU, this is just for power delivery. Fan module is a cooling system. Okay, so that's it, guys. Any question? Any question, guys? Any questions, guys? All right, so the next one will be the key technologies. We have the BMS and the BIOS. So these are the two technology that we can find in servers. So the BMS will just be the baseboard management controller, and then we also gonna have the BIOS. So the BIOS is the basic input output system. So the BMS will just be your what you call that? Just a microcontroller, which is on the motherboard, which can provide some sort of management in terms of managing how the server how can the server behave, or how the server can behave if it's powered off, okay, or if the operating system is down. How does the server behave? So that's the role of the BMC. Why am I saying BMS? The BMC. Okay, so it's kind of a remote server management. So you can manage your server via maybe an IP address. So you manage the server from a different distance. So it can help in terms of turning on and off the server, rebooting the server, and maybe to perform a scheduled power operation. So that is the role of a BMC. Okay. So and then the BIOS is basically the firmware of the motherboard, where we call it it's on the ROM memory. So this is basically the memory of your computer. So the firmware, before you can even put the operating system, the software. When you buy a computer, before you can even have Microsoft Word for a Microsoft Windows on it, that operating system that is controlling the computer, that's the BIOS. That's the firmware of the firmware that is stored in the ROM of the motherboard, read-only memory. So that firmware that is built there is the BIOS. So if you switching on your computer, before it can go on, if you maybe hold a key, it can be even F12 or any key, you hold it. That system that is going to show you there, that's the BIOS. Okay. All right, guys. I think that's it for today. We're going to pick it up tomorrow. Okay. So just for you to understand these two, the BMS is just a remote manager, which can help you to monitor and control the server from a distance using an IP address. And the BIOS is just a starter or a software which is like to initialize the whole hardware or to boost the operating system. So it's stored on the ROM. All right, guys. I think that will be this will be all for today. Any question? In the meantime, you can turn on your camera, then we're gonna take the attendance, and then